Okay, so what we were discussing yesterday was different examples of ideals and factor rings. So today we are going to introduce a new type of ideals. So this is known as prime ideal. So let me first write the definition of it and then we will understand. So what is the definition of prime ideal? A prime ideal of a commutative ring R is a proper ideal of R such that AB belongs to A implies either A belongs to A or B belongs to A. Okay, so the prime ideal, for ideal I'm using the notation capital A. It can be I, whatever notation you can use. So this is the meaning of the prime ideal. So let's understand word by word. So first of all, we should have a commutative ring, right? And then we should have a proper ideal of that ring. So I hope it's clear what do we mean by proper ideal, because for every ring we have two improper ideals, the zero ideal and the ring itself. So the ring itself is always the trivial ideal of every ring. So other than the ring itself, if there is any other ideal, so we call it a proper ideal. So it is said to be a prime ideal if this condition is satisfied. That means if A into B, this kind of element belongs to that ideal, then this will imply either A belongs to that or B belongs to that, right? So I hope this is clear. So we'll do examples and then it will be better clear that whenever the product of two elements is there, so that means one of them is there or both. Obviously it's covered, that possibility is also covered, that or both it is there. So let's see through the examples, right? So let me give you the example of the prime ideal. So you have Z, which is the ring of integers. So we have already discussed that NZ is the ideal. So all subrings, all ideals of Z looks like NZ, any multiple of Z. So NZ is always an ideal of Z. So now, because this is the type of all the ideals of Z, so now we want to know that out of these ideals, which one is prime ideal or which one is not prime ideal, right? So the result says NZ is a prime ideal of Z if and only if N is prime, right? So this is an exercise. Its proof we will do later, but this is the exercise, this is the result. I'm telling you this, but we need to prove this one, that this is going to happen, right? So I'm giving you some time, you can think about it, how you're going to prove it. So you can prove just by using the definition of the prime ideal. So right now I'm not going into proving it, we'll come back to this later. uh, for the time being you can just treat it as an example, like 2Z, 3Z, 5Z, 7Z, right? Uh, 23Z. So these are prime ideals of Z, right? And then we can have few other examples. And one, okay, this is, you can say, example number one in for the ring of integers. In this, the first example is of this kind, and second is zero. So zero is also a prime ideal of Z. Its proof is very simple, so we can do it very quickly. That why zero is a prime ideal. So zero ideal, right? So like here I told you that every ring has two ideals, zero and the ring itself. So the ring itself is always a improper ideal, and zero ideal is always present in every ring. obviously 0 is considered as a proper ideal because 0 is a proper subset of R. So it is a proper ideal. I just want to show it's a prime ideal. So for that I need to show that if the two elements product belongs there, then one of them definitely belongs there. So it's very easy to show that 0 is
मैम एक बार प्रीवियस पेज दिखाना.
okay.
मैम प्राइम आइडियल होने के लिए बस वो प्रॉपर आइडियल होना चाहिए, क्योंकि ये जो प्रॉपर्टी है अभी आइदर ए बिलोंग करेगा बी बिलोंग, ये तो वैसे भी आइडियल में होगी.
नहीं क्यों?
आइडियल की डेफिनेशन से
उल्टा होता है बेटा, उल्टा ट्रिवियल होता है. मान लो A बिलोंग्स टू A है और B बिलोंग्स टू A है, we always know their product will be there. This is by default satisfied because ideal, ये तो सब रिंग में ही होता है, आइडियल में भी होता है, सब रिंग में भी होता है. We are saying the opposite of it. Like this should imply this. अगर दो एलिमेंट्स का प्रोडक्ट वहां पे है तो वो दोनों इंडिविजुअली, दोनों में से इंडिविजुअली वहां पे कोई ना कोई जो है जरूर होगा. दिस इज व्हाट इट मीन्स. I'll explain with the help of example. Let me just first prove this, then I will explain with more examples that what does this mean. Is it clear? जो आप कह रहे हो कि आइडियल की डेफिनेशन में हमेशा ये होता है, वो ये होता है कि A belongs to A and B belongs to A definitely implies A into B belongs to A. और में भी हो जाता है, मीन्स दूसरा एलिमेंट अगर रिंग का भी है, उस आइडियल का नहीं है, तब भी उनका प्रोडक्ट आइडियल में होता है. वो आइडियल की डेफिनेशन है. अब हम प्राइम आइडियल के लिए कह रहे हैं इट हैज टू बी सेटिस्फाइंग दिस, दैट वेन एवर A and into B belongs to A, this implies either A belongs to A or B belongs to A, right? Is that fine?
यस मैम.
Okay, so let me just prove this one first. 0 is a prime ideal of Z. So 0 is a prime ideal of Z. This is what I want to show. So I already know that 0 is a proper ideal of Z. Only thing I need to show is that the product of two elements belong there. So 0 ideal में कौन से elements होंगे? Yes. What are the elements in the 0 ideal? Only 0. It's just one element. It's written directly, it's written over there. 0 ideal में सिर्फ 0 elements है. 0 ideal is the ideal generated by 0, the principal ideal generated by 0. So it's 0 times Z. So it contains only one element, that is 0 only, right? So if let A into B belongs to 0 ideal. So A into B belonging to 0 ideal का क्या मतलब है कि वो 0 ही होगा, क्योंकि 0 ideal में एक ही element है और वो क्या है 0. It contains just one element. This is the notation itself is telling you, right? I'm enclosing just one element, that is 0. Is it clear कि 0 ideal में सिर्फ 0 ही होगा?
यस
Right?
मैम.
तो 0 ही होगा मीन्स अगर कोई एलिमेंट उसको बिलोंग कर रहा है तो वो एलिमेंट हैज टू बी 0. तो मैंने अब लिख दिया इट इंप्लाइज ए बी इज इक्वल टू 0. अब ए बी इज इक्वल टू 0 इंप्लाइज आइदर ए इज 0 और बी इज 0. अब ये कहां से आया? वाई दिस इज ट्रू? बिकॉज वाई दिस इज ट्रू? इज इट ऑलवेज ट्रू कि दो नंबर्स का प्रोडक्ट 0 है, किसी भी रिंग के दो एलिमेंट्स का प्रोडक्ट 0 है तो वन ऑफ देम हैज टू बी 0? ये कब होता है?
जब कोई प्रॉपर डिवाइजर ना हो.
Unintegral domain. The integral domain. Proper divisor is not making a sense here. I didn't
मतलब
understand.
प्रॉपर जीरो डिवाइजर ना
Zero
हो.
divisor. Just say zero divisor. And there is no word like proper zero divisor. It's a zero divisor. So there are, because Z is an integral domain, so no zero divisors. Right? So that means one of them has to be 0. If one of them has to be 0, it implies A belongs to this or B belongs to this, because equal to 0 means it belongs to the 0 ideal. So done. It's a very trivial proof. Hence proved. Because we just need to show the definition that if product of two elements belong there, then one of them belongs there. So this is done. Is it fine?
Yes, ma'am.
Right? So let me just take more examples. Mm, and let me give you another example where we do not have a proper ideal. Say you can have example of x square
हम
plus.
एक बार प्रीवियस पेज करना.
Okay.
Okay, thank you, ma'am.
Yeah, just minute. Give me 1 minute. There's some problem with the internet connection. I need to switch over the network. I'm feeling disturbance. I'll change the network.